क्या हाँ, NO3. So in the atmosphere there is the unburnt hydrocarbons. So then there is the formation of a nitrate in this one. This one is the that nitrate radicals that should be starts the chain reactions from a aldehyde that is present in the atmosphere. NO3, CHO. There is the formation of a RCO, this one, plus HNO3. This is the NO3, radicals, plus HNO3. So these are the formation. Here R is the alkyl group. Alkyl radical is formation in this one. And after that, nitrate radicals that is converted into NO3 plus NO2 radicals. This one is the, so there is the formation of a N2O5. This should be happens in a nighttime reaction. There is the formation of a dinitrogen pentoxide. This one is the nitrogen dioxide radicals and nitrate radicals. These are the. Further that should be, this should be formation in the night time, and then after N2O5 plus S2O, so there is the formation of a twice HNO3. This one is the, so these nitric acid that is formation in a night time. And then after, when the formation of this one, so that is also they have produces the pan in the atmosphere. NO2, so then there is the formation of a RC oxygen O2 NO2. This one is the pan. This is the secondary pollutant. This is the peroxyl acetyl nitrate. And that should be removed by the ammonia. NO3, so there is the formation of a ammonium nitrate. So this is the neutralization position here. All the radicals they have neutralized in this one after the conversion of HNO3 to ammonia that is present. So there is the formation of ammonium nitrate. And some of the which one is forms in the HNO3 in the atmosphere, so that should be washed out from the rain. Now another is the sulfuric acid is causing for acid or another pollutants. Another causes sulfur dioxide. So sulfur dioxide, how that should be produced in the atmosphere? So suppose hydrogen sulfide, carbonyl sulfide, carbon disulfide, methyl mercaptan, dimethyl sulfide, dimethyl disulfide. So these are when that is presence in the atmosphere. Then after that is going further reaction of a sulfuric acid. Because the sulfur compounds, which one is released in the atmosphere in lower state, -2 oxidation stage. अब suppose when atmospheric production and removal of sulfuric acid. This is the S2S. This one is that should be react with the hydroxyl. So there is the formation of S2O and this radicals. Another is the carbon disulfide is present. CS2 hydroxyl radicals. So then there is the formation of a COS plus hydroxyl. Carbonyl sulfide, COS, suppose this one is the, so that should be produces the CO2 plus SH. So these thionyl leads to production of a sulfur dioxide, SH group. This one is the in the atmosphere when that is present, so they have oxidized. There is the formation of a SO plus hydroxyl radicals. O3 that should be oxidized. HO plus O2. Per hydroxyl radicals. These are the. So here the SO should be react. Oxygens oxidized with the oxygens are ozone or NO3. So they have formed the sulfur dioxide. This one is the and other products. So this should be a sulfur dioxide that is comes in the atmosphere. There in the aquatic life, there is the sulfur dioxide that should be produced by the microbial activities. Some of the algae they have produces these sulfur dioxides in the aquatic, and then after that sulfur dioxides oxidize. So sulfur dioxide is SO2 is ultimately converted to sulfuric acid. S2SO4. Now how this should be happened? So in the atmosphere, these sulfur dioxides, suppose that is presence in the atmosphere, SO2 plus hydroxyl radicals in the presence of third body, there is the formation of a SO2. This one. M is what? M means nitrogen, oxygens, or any other some of the soot particles. These are the where the reaction that should be provides. After the formation of this one, SO2, this radicals react with the oxygens, formation of a peroxide radicals, SO3 plus M. And SO3 that is dissolved in the water. H2O. So then there is the formation of a H2SO4 sulfuric acid. अब hydroxyl radicals that should be produced to nitric oxides. Hello. So this one is, suppose hydroperoxyl radicals that should be produced to a nitric oxide. How this should be? So this is NO hydroperoxyl radicals. So they have produces the hydrogen dioxides and hydroxyl radicals. So these nitrogen dioxides react with the hydroxyl radicals and convert into a nitric acid. NO2 plus hydroxyl radicals in the presence of third body M. Then they have produces the HNO3 plus M nitric acid. These sulfur dioxides that should be react with the heterogeneous reactions in there. So sulfuric acid that should be produced in the heterogeneous process. When the required reactants are available in cloud droplets, because in the clouds there is the presence of these droplets. So there is the presence in this one. So then after there is the heterogeneous reaction that should be started. How this should be? The SO2 in the atmosphere, that is in gaseous. Then after that should becomes in a aqueous soluble. SO2, these aqueous react with the water droplets, formation of a, this one is the aqueous plus S3O aqueous. After that HSO3 aqueous, hydrogen sulfide, they react with the water molecules, formation of a SO3 plus S3O. Hydrogen peroxides, SO2 negative charge plus S2O. The name of this one is peroxymonosulfide. When the peroxymonosulfide, so there is the rearrangement of this one, because the structure of this peroxymonosulfide is sulfur oxygens. Oh yes, this is the structure peroxymonosulfide. So there is the rearrangement to form a hydrogen sulfate. What is the rearrangement of this one? So they have formed the rearrangement, and then there is the formation of a sulfate, hydrogen sulfate. This one is it. So this is the HSO4. Then after that is converting into a S2SO4. Sulfuric acid. अब overall reactions, if we are seeing this in this one, so that is in the atmosphere. This is the summary of this one. We have the sulfur dioxide, dimethyl sulfide that is present. that is DMS. Then after they are producing sulfur dioxide, SO2. These are the direct emission. From automobiles are where the fuel combustion is there. So they produces react with the hydroxyl radicals and formation of SO3 plus S2. So there is the formation of a H2SO4. This one is the aqueous. Another reactions. There is the formation of H2SO4. This one is the. So that is in clouds. Mist, heterogeneous reaction. Then after that should be rain, snow. These are the present in the atmosphere. So then there is the heterogeneous reaction that should be start. This should be happens H2O2 or O3 in water droplet. So this is the atmospheric overall reactions in the atmosphere, that is converting the sulfur dioxide into a sulfate or sulfuric acid. H2SO4. How that should be removed? So there is the ammonia is present in the atmosphere. Then there is the NH3, H2SO4, NH4, HSO4. This one is the twice NH3 plus H2SO4. So then there is the formation of a ammonium sulfate, SO4. So this is the termination point. All the free radicals when that is present converting into sulfuric acid. So this sulfuric acid that should be removed by the ammonia, that should be neutralized by the ammonia, or another that should becomes in a rainwater. Understand this one? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now another thing. Ozone. So all of you know this one, good ozone, bad ozone. This is the two types. So ozone that is present in the stratosphere. This one is the good ozone. That should be protects the life on the earth by the absorbing of ultraviolet rays. Second, ozone. Second, bad ozone that is present in the troposphere. That should be causes the irritation, damage to plants, animals. This is the highly oxidizing agent. So that should be oxidized and it should be also involved in a greenhouse gases. Suppose if we can classify these ozones on the basis of a biological point of view. So that is ultraviolet A, that's UVA, UVB, and UVC. This one is the 280 nm. And this is the 0.5% of the total solar flux. And that should be damaged, rapidly damaged to living matters. UVB 282, 315 nm. That is total reflects to 1.5% of total flux. This one is harmful to both plant and animals, This is UVA 315 to 400 nm. Near to this one is the near to visible region. So that should be 7% of the total flux. And this is not harmful to living organisms. But these are two that should be harmful to the living organisms. Which one is presence in the atmosphere in the which layer? That is the presence in the troposphere. So in the stratosphere and troposphere, both are the presence ozone. So in the troposphere, that is a bad ozone, and in the stratosphere, this one is the good ozone, because that should be protected to the living organisms by absorbing the ultraviolet rays. Now in troposphere, in the stratosphere, what are the reactions? So there is the formation of the ozone, and another is the decomposition of the ozone. That is so how this should be happens in the atmosphere. So synthesis is the synthesis of ozone. Synthesis. The oxygens, they have absorbed the energy 240 nm, that is lambda. So there is the formation of it. Atomic molecule, two atomic molecules of oxygens. These are the slow reactions. Another atomic molecule, presence of third body. So then they have produces the ozone. And this one is the fast reaction of decomposition. Decomposition in the atmosphere. Ozone O3. They have absorbed that energy. That is 200 nm to 315 nm wavelength. They are producing excited molecules of the oxygens plus atomic molecule. That is fast reactions. Then after oxygens plus O3, so there is the formation of a molecule of oxygens, and this one is the slow reaction. So the production of two odd oxygens, which are both in triplet ground states. And now how we can calculate this one? Yeah, how much energy that should be released? So here we assume that the enthalpy change is independent of temperature. This is the enthalpy. Delta HF, formation of two atomic molecule of oxygen. This one is in the gaseous, minus delta HF, production of oxygens. This one is in gaseous. So that is 2 multiplied 249.2 minus 0. So that should be produces a 498.4 kilojoule per mole. So for this energy 498, so there is the first reactions. That should be releases 498. Energy is energy, that is H nu, 498.4 kilojoule per mole. Now wavelength is required for this process, so that is lambda Hc Na pani. This formula all of you know. So 6.626 would 10 to the power minus 34 joule would 2.998 10 to the power 8 meter per second multiply 10 to the power 9 nm per meter multiply Avogadro's number multiply to 6.022 would 10 to the power 23 mole per mole. This one is so that is divided by 498 joule per mole. So that should be calculated. So that is 240 nm. So for that energy produces for production of this one, so that is required say lambda 240 nm. अब enthalpy change for the ozone formation reaction. This one is the Chapman reaction by the Chapman scientist. Now he has calculated the value. So enthalpy change for the ozone formation reaction enthalpy change for ozone formation. Delta HF, that is O3 ozone, minus delta HF, atomic molecule of oxygens, minus delta HF oxygen. This one is the, so that is equal to 142.7 minus 249.2 minus 0. So that is 106.5 kilojoule per mole. So enthalpy change for the photo dissociation of ozone into excited species. Enthalpy change photo dissociation of ozone into excited species. So that is delta HF equal to delta HF oxygens plus E energy of oxygens plus delta HF O2 gas plus energy O2. This is the O2 minus delta HF O3. This one is the gases So that is equal to 249.2 plus 190 plus 0 plus 90 minus 142.7. So that should be calculated 337 kilojoule per mole. The absorption with consequent decomposition is the process that protects the earth from harmful ultra radiations. Mechanism of the destruction or decomposition of ozone. This one is the catalytic reactions that should be happens in this stratosphere. So that's why this is the much more depletion of the ozone or thickness of the ozone that should be reduced. So this one is called a ozone hole. What is the catalytic reactions is there in the atmosphere? The catalytic decomposition of ozone. So here we general mechanism of this one. X plus O3. There is the formation of XO plus oxygens. Another reaction XO plus O. So then there is the formation of a X plus O2. Net reactions is that. So that is O3. So that should be decomposed and converting into 2 molecules of oxygens. Here X is what? Here X is a catalyst. What are these? X is HOX. In this includes hydrogen radicals, hydroxyl radicals, and peroxyl radicals, which are present in the stratosphere. In the troposphere, that is also these are the present. NOx, NOx is the another catalyst. So in this one, NO and NO2 radicals. These gases that is present in the lower stratosphere. Another is the CLO that is present, chlorine monoxides. So in this one, that it means chlorine radicals and chlorine monoxide radicals. So these are the catalysts which decomposes the ozone. Now how that should be react in the atmosphere, or how the hydroxyl radicals that should be comes in the atmosphere. So these hydroxyl radicals that is present in the stratosphere due to the water processes of a hydroxyl radicals. So oxygens, atomic molecule of oxygens plus H2O, they produces the 2 hydroxyl radicals. First, second, H2O, they have absorbed that energy, then they have produces the hydroxyl radicals and hydrogen radicals. These are the, so that should be comes in the atmosphere. Now hydroxyl radicals decomposes the ozone layer. This one or this one. So they have decomposes the ozone layer. How this should be happens? This is the X plus O3. So then there is the formation of a hydroxyl per radicals and oxygen molecules. Another this one atomic molecule of oxygens. So then they have produces the hydroxyl radicals plus O2. Overall net reactions, how much this should be decomposes. So that is the oxygens plus O3. So they have produces the 2 molecule of oxygen. Same thing is there if we have applied the hydrogen radicals is there. H, X, this one is the X, this one is the O3. So then there is the formation of a OH plus O2. OH plus atomic molecule of oxygens. So then they produces the hydroxyl radicals plus oxygens. So this should be decomposed as how much? Oxygen O3 twice O2. They have decomposes the 2 molecule of same thing. Decomposition by NOx species. NOx species. This one is the and NOx is what? So NOx is this is the NO and NO2. Combined name of this one NO and NO2 is NOx. How they can? So first reactions N2O, they have absorbed nitrogen plus oxygens. N2O, atomic molecule of oxygens, excited molecules. This one is the, so they have produces it twice NO2. Another reactions, nitrogen plus H nu, they have produces it. These radicals nitrogen plus oxygens. So again they have produces it NO plus N. Then nitrogen plus oxygens, so NO plus O. It's not N. N is the one of the molecule. NO plus oxygen, atomic molecule of oxygens. So once nitric oxide has been produced and it can take a part in the decomposition of the ozone or catalytic process of the ozone. NO, this is the X, react with the O3, then the formation of a NO2 plus O2, NO2 plus atomic molecule of oxygens. So they have produces a NO plus O2, overall decomposition O plus O3 twice O2. So 2 molecule of oxygens, that is converted. Nitric oxide is also react with the hydroxyl radicals and that should be produces a acid. If you have remember previous reactions, NO plus hydroxyl radicals in the presence of third body, so then there is the formation of a HNO2 plus N. This one is. Another reactions that is presence in the atmosphere, chlorine monoxide. When the chlorine atom that is presence in the atmosphere, so that's lifetime is near about 1 year. So some of the microbial activities or human activities, these chlorine atom that should be produced in the atmosphere. So catalysis of chlorine containing, that is ClOx species. The burning of fuels are due to the microbial activities or eruption of volcans. So these chlorine radicals, they have comes in the atmosphere and that is present in a 1 year. Its lifetime is 1 year. CH3Cl plus hydroxyl radicals. So CH2Cl plus H2O. This radical that should be produced in this. So a small amount of this compound that should be migrates into a stratosphere, and then after photolysis reaction that should be starts. So that is produces a atomic chlorine radicals. 10 मिनट वाली 10 मिनट बस CS3 Cl. So these chlorine radicals that is present in the atmosphere, then after further reaction that should be start. Cl plus O3, the formation of a chlorine monoxide radicals plus oxygens. Then after ClO, these radicals they have react with the atomic molecule of oxygens. So then they have produces a the chain reaction that should be starts. Chlorine that again that is produced oxygens plus O3 twice O2. 2 molecule of oxygen that should be destroyed in this one. Another hydroperoxyl radicals, they have react with this one, formation of a chlorine monoxides, ClO. First they have formed the hypochlorous, and then after there is the chlorine monoxide is formed. Hydroperoxyl radical that is present in the atmosphere. This one, ClO. HOCl is hypochlorous. HOCl, they have absorbed that energy. Then they have produces the hydroxyl radicals and Cl radicals in the atmosphere. So again, Cl that should becomes in the atmosphere. Then after that should be react formation of a chlorine monoxide. Cl is the X, O3, ClO. ClO is chlorine monoxide radicals. Is there? So they have formation of this one. Hydroxyl radicals plus O3. The hydroperoxyl radicals they have forms plus oxygens. The overall net reactions is what? That is ozones. They have decomposes this one twice O3. They have destroyed the ozones. 2 molecule of ozone that should be destroyed here. BRO. Another is these are the BRO, bromine monoxides radicals, ClO radicals. So they have produces the bromine plus Cl radicals plus oxygen. So again both are that they have destroyed this one. So Br is the X. So in this one, ozone, BRO plus O2. BRO plus oxygens. So then they have produces the bromine. If there is the presence of a Cl, so then Cl is here. So Cl they have react with the ozones. So thus overall they have consumed the 2 molecules of the ozones. So that's why they are highly harmful to the ozones. Chlorofluorocarbons is another. Here we should not write the reactions of this one, bromine and fluorine. If there is the presence in the atmosphere, there is the chlorofluorocarbons. So this one is much more harmful, and that is much more involved in the removal of decomposition of ozone, because the chlorofluorocarbon that should be persist in the atmosphere in several years, near about 45, 100 years, 85, 300. Some of the chlorofluorocarbon as CFC 115 that should be available persist in the atmosphere 1700 years. And when that should be migrates into a stratosphere, then photolytic reactions should be starts. So this, suppose one of the examples, CFCl3 plus H2. So they have produces the CFCl2 plus Cl, these chlorine radicals. Again, Cl plus O3.
Hello, sir.
Huh.
Sir,
Yeah.
we will have our next class from 10, sir.
Okay. Just we complete this one. Cl plus O2. So again, overall reactions here oxygens plus ozone. So they have decomposed the 2 molecule of the oxygen. So this is the decomposition. Further reaction, suppose fluoride, bromide, iodide. So they have reduces or decomposes the much more ozone. Okay, now today we leave this class, and I think yes, your time should be start. In next class we start the photochemical smoke. Okay, so now we close this session. Just a minute.